Hello everybody, Jim Hannon from Golden Stars, and tonight we're doing the star size, or the star side of that name, Golden Stars. And if you notice, those of you who saw my other telescopes, we're using a different instrument tonight. This telescope is called a Maksudov Cassegrain design, and it's a long focal length telescope, and yet this tube is much shorter than the other white telescope I used to use. The reason for that being is the old telescopes, the type the old sea captains used to use, they had a lens up in front, they focused the light back and out an eyepiece out the back. And that's the way the type of telescope I'm using, or I used earlier, the white telescope. That's the same type of scope that is. This design is completely different. It's a short tube. This black part up here is nothing more than an extension I did for dew protection, and then the dew heater is on here, which is plugged into a battery. But the whole telescope tube is only about from here to back here. It's only about 14 inches long, yet it's got a 60-inch focal length. How is that possible? Well, the light comes in up here. It goes through a meniscus type first lens, field lens, that directs lights back down here to a main mirror, which is 5 inches in diameter. This is a telescope that's an inch bigger than the 4-inch I used. The light bounces off of that mirror back up to a secondary mirror that's mounted on that meniscus mirror, or glass that allows the lens in, or the light in down to the mirror, and it goes from that mirror back down the tube again, and through this assembly and back through the filter system and the camera. So it's folding the light back and forth, giving it much longer focal length. Now there's a drawback to that. Those of you who do photography know a wide open lens, say at 2.8, is much faster than a lens working at f12. This telescope is working at an equivalent of f12, and the reason I'm doing it is because the galaxy I imaged last outing was with the 4-inch telescope, and that's only a 28-inch focal length compared to 60 for this. The galaxy came out very small, came out nice, but I am doing a total experiment here. This may require very, very long exposures because we're using what's called a slow F ratio system. So it's kind of like the same thing as taking a flashlight and pointing it in a wall in the dark 3 feet away. You get a really bright image. Back up about 20 feet, shine the same flashlight on the wall, and you get a much bigger throw of light, spread out a lot more, and it's a lot dimmer. So basically that's what we're doing here. The end result will hopefully be a galaxy with plenty of detail and much larger, but I'm probably going to have to use much longer exposures. So we will see how that works. We're almost done setting up. It's getting near sunset. There's my batteries here, and there's one inside with the computer. I will be back later on and let you see what those images look like as they are coming in. And I sure am hoping for a good night, and it's going to be a chilly night at that also. It's a little breezy left over from that storm, and as the wind dies down, the temperature's going to really drop. Talk to you a little bit later, guys. Hi guys, Jim Hannon back here from Golden Stars, the star side of the golden tonight. You're looking at the galaxy NGC7479, I take that back, 7479. This is a red image coming in. It's rather weak. You can see the nice bar and the spiral arms coming off. And what I've done tonight is used a much longer focal length telescope, but the F ratio is much lower. And this is just a test to see if it's going to work. It will work. It's just exposure is going to have to be a lot longer. And I ran into a computer issue where I had to switch over to a backup computer tonight and get that other computer straightened out before I do it again. But let me just show you what the white image looks like. You can see how much stronger. There's the galaxy there and all its splendor, the bar, the beautiful arms coming off of it. That's in what we call luminescent white light. That's about 45 minutes worth of data. And here I'm just started collecting the red, and you can see how much weaker it is right now to collect more. The experiment's working. I'll be able to use this telescope to image some galaxies, which my other telescope, they were just way too small. The focal length it's great for wide objects like large galaxies and gaseous nebula and things like that. It works great with that. But this Maksutov Cassegrain with a 60-inch focal length is really pulling up this galaxy really nice. It's going to work great in the future. I just got to make some special brackets so I can put things together. I want to put a longer focal length guider on it. The guider that's on here is only a 60 millimeter 50 millimeter lens guider, and it's struggling to keep these stars nice and round. It's not doing too bad of a job, but it would do better if I put a little bigger scope on it as a guider scope next time. But pretty interesting. We're coming up, we got about 88 seconds, it looks like. We're coming down to 84 seconds, 83, 82. That's the countdown. You won't see much of a change. I'll leave it on until that changes. Adding one image on top of the other is what it's doing. And what it also does is when it does that, it smooths out the background. So when you process the images, they come out much smoother. The graininess that I can see on the screen here from just a couple of images stacked one over top of the other, you even that out in the processing, and it really makes a big difference. We're hanging now. We'll see we're down to 48 seconds. We'll see if we can see a little bit of a change, a little bit of an increase. I can go over here and play around and increase, but it'll show a lot more of the grain. There you can see it's stronger there. I'll leave it there till the next image comes in. What I'm playing with here has no effect on how the final image will be processed. It's just how it displays it on the screen. You can see those outer arms a little better with this higher setting, but also the background is much grainier, which, again, I'm not worried about that. This exposure is not going to be much longer than probably an hour and 50 minutes. It's just an experiment, and I had some problems, like I said, with the computer earlier, so I'm going to have to cut this short, but I'm going to get a halfway decent image. And there it goes. It just changed. I don't know if you saw any kind of a flash there, but it just smoothed out the background more. That's the fourth image in this set, so that's a total of 16 minutes. Each one of the images I'm taking is 4 minutes long, and they get added together. That was the fourth one, so now that's 16 minutes in red. So things are going pretty good, guys, and I'll try to show you some kind of a finished image at some point, but it was an experiment. Had some problems early, but in the end, things are working out pretty good. Take care, guys. Hey guys, Jim here, and I'm back again. Just forgot, you're looking at the green light coming in now. This is a green image. You can see it's very weak. That's just the first 4-minute exposure. Got to tell you, this galaxy that we are imaging here tonight is 110 million light years from Earth. That's a long way. In other words, the light that's entering my telescope and producing the image on this computer left that galaxy 110 million years ago. And if I can go back to the original white image just to show you, I mean, look at that galaxy. That's a gorgeous galaxy. Should get a decent image out of this, even though it's a very short exposure. It's only going to be a little short of 2 hours. I may come out in future nights and add more data to this, because this galaxy is absolutely beautiful. This is the way the red light, and this is only 24 minutes of red. You can see the arms, and that's the red that'll get added to the color. This is the green data, which is now coming in there. You can see it's pretty weak. It's just building, but that's only the first 4 minutes. That'll be building up. And then I have blue data, and I'd like to get a little extra blue in there before I finish up. And if I get something halfway decent, which it looks like I will once I put everything together, I may just have to come out and add some more data to this over the next couple nights and push it up to several hours, 4 or 5 hours worth of data, and I should get a really nice image, especially going off of the way that what we call the luminous image looks. Look at that. Look at the detail on there. And it's actually burned out in the center, which we will take care of and process and bring a lot of that out. So Again, this galaxy, 110 million light years from Earth, and having some fun with it tonight. Take care, guys. Okay guys, Jim Hannon here from Golden Stars, and this is a processed image of the galaxy NGC7479, 110 million light years from Earth, and it is not what I would call a great image. I had several problems last night which really cut my imaging time down. There's only about 2 hours and 15 minutes of data in this image. With the focal length that I was using of that F12 long focal length telescope, I probably need to go at least 5 or 6 hours to smooth out this data and get a much better image. Not sure how much of this you can see in this arm here. There's some very interesting bumps in here. You can see where they look like little pearls, heavier star formation, and you can see that arm continuing around up here. The other side, you can see it's a broader bluish green arm here, extending the side, and very kind of indistinct. Now something like that would require imaging in the order of several more hours to really bring out. The central bar, of course, is very strong, and in fact it's probably a little bit overexposed, but I couldn't do too much processing on this imaging because there just wasn't enough data in the image. There was too much graininess in it because of the shortness of the exposures. But what I did prove to myself was that I could image with that F12 slow telescope and imaging faint galaxies. It's just that it's going to take longer exposures. Like I say, this exposure is probably 2 hours and 15 minutes total. There's something like 48 minutes of luminous data, and around 24 minutes of red and green data, and the blue I went a little longer. I went around 40 minutes, and that was it. I gave up for the night because of some technical issues which have now been completely cleared up thanks to a good friend of mine who is very computer savvy. Straightened me out there, but I'm happy in the fact that I've got an image of a very small galaxy, and I got it fairly large on the screen, and it just indicates that my exposures need to be a bit longer. So not a total waste of time. Quite happy that I got this much data out of it. It's just that with working with an F12 instrument, it's slow photographically. So it's just a matter of time, adding more and more exposures to just smooth out and deepen the background. So that's it for this series, guys, and we'll see you on the next trip.